Okay, let's solve some equations involving exponential functions. Um, so these might be easier to solve if we could use logarithms, but we haven't covered those yet. So if you know how to use logarithms, just pretend you don't. Um, so first off, whenever we're solving equations involving exponential functions, something that we want to do to make it a lot easier for ourselves is put everything in the same base. All right. And remember your base, that's the big number on the bottom that we raise to some exponential power. Okay, so look at this first equation. You have 3 to the x squared on top, 27 on bottom, equals 9 to the x. What's the smallest base that you see? The smallest base is 3. All right, so we're going to write everything in base 3. So we have 3 to the x squared. Now 9 in base 3. Well, 9 is 3 squared. We know that. And if you multiply by 3 again, you get 27. So 27 is 3 cubed. Okay, so we're going to write 3 cubed on the bottom. We'll substitute 3 squared for 9, x on the outside. Let's simplify a little bit here. So using our exponent rules, we know that on the left, when we divide bases, we're going to subtract their exponents. So this would be 3 to the x squared minus 3 equals, when we have one exponent that we're raising to a power, we're going to multiply those two exponents together. So this would be 3 to the 2x. Okay. Now, the nice thing about our equation now is since we have everything in base 3, we only have to worry about the exponents. In order to make this equation true, you need the exponents to be equal to each other. So really, we're just solving for the exponents here. Okay? And now this is like a little algebra 1, algebra 2 problem. You know, I see it's a quadratic, so I'm going to move everything over to the left, set it equal to 0. If you need to pause the video and work on factoring it, go for it. I'm going to factor this. X plus, let's see, multiply to negative 3, add to negative 2. That would be x plus 1, x minus 3. Okay, set it equal to 0. That means that our solutions would then be x equals negative 1 or positive 3. So either of those solutions would work. Okay, excellent. Moving on to number 7. So number 7, we have some 64s. I have a 4. So I'm going to do the same thing. I'm going to put everything in base 4 because 4 is the smallest exponent or smallest base that I can see. So let's see. So 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. So anywhere I see a 64, I'm going to substitute 4 cubed. Okay, times 1 over 4 cubed equals 4 squared. So I think we have a few ways of solving this. There's not a single right way to do it. Personally, I think it might be convenient if we moved the 4 cubed that's on the bottom of this fraction here, if we moved it up. So I'm going to multiply both sides by 4 cubed, or 64. So that's going to go up on the right here. Okay. Now, when we're multiplying our bases, we'll add our exponents. So on the right, I have 4 to the 5th. On the left, I'm going to multiply my exponents. So I have 4 to the negative 9w. Okay, I'm solving for w. And now it's easy. It's just like before. You know, if we want to solve this, we need the exponents on the left to be equal to the exponents on the right. So negative 9w equals 5. Really easy algebra 1 problem. Divide by negative 9 on both sides. So w would be negative 5 over 9. All right. I'd like you to take a moment, see if you can solve number 8. So go ahead, pause the video, try to solve number 8 if you can. I think you can. I believe in you. All right, let's look at my solution here. So I see that I have a 16 and a 4. Okay, my smallest base is 4. So I can write 16 as 4 squared. So I have 4 squared to the 2r plus 3. I have 1 over 4 squared to the 2r. So what can I do from here? We have a few options. I'm going to rewrite 1 over 4 squared as 4 to the negative 2. Okay, our exponent rules say that if I have an exponent on the bottom, I can flip it and make it negative, or vice versa. Let's simplify this. So I'm going to multiply my exponents here. So I have 4, 2 times 2r, so that'll be 4r plus 6. Okay. I guess I don't really need those parentheses, do I? Oh well, it's not hurting anything. From there, now remember there's a little 1. Our exponent here is a 1. From there, I can add my exponents. I'm multiplying the bases here. So 6 minus 2 is 4. So I have 4 to the 4r plus 4 equals 4 to the 1. From there, again, same as before. Okay, it's only 3 problems in, and we should have established a routine by now. Okay, we've gotten it to the point where I have 4 to something on one side equals 4 to something on the other side, right? Those exponents have to be equal to each other in order to make this equation true. So we'll say 4r plus 4 equals 1. Go ahead and solve for r. Move the 4 over, so 4r equals 1 minus 4, negative 3. Divide both sides by 4. So we have r equals negative 3 over 4.